Hey guys, welcome to the SaadPyTech, the Python programming channel. And today we are going to learn about the data structures and what is pandas in Python. So this video is going to be exciting and we will be learning the essentials like how to handle the missing data, the data operations, the merge, the grouping, the time series, the plotting, the pivot tables, and many other things that are basic and essentials in handling your data. So how Python operate these and what libraries and modules do we have to import in Python? We gonna be learning today regarding the pandas library and the numpy, and we will be understanding the basic preliminaries like series and data frames in pandas. So the question number one is like, what is pandas in Python? Like is an open source Python package that is most widely used for data science, data analysis, and machine learning tasks. It is built on top of the another package named NumPy, which provides supports for multi-dimension arrays. And where and what can do the data frame be using in the pandas? Pandas make it simple to do many of the time-consuming and repetitive tasks that we normally do in our routine work, and that we usually play with data. This include like data cleansing, data fill, data normalization, merge and joins, data visualization, statistical analysis, data inspection, loading and saving data, and much more. So what is basically the data structure and how we structure the data? So over here we are giving an introduction to the data structure. We will start with a quick and non-comprehensive overview of the fundamental data structures in pandas to get you started. The fundamental behavior about the data types, indexing, and access labeling alignment apply across all of the objects. To get started, import NumPy and Node Pandas library into your Jupyter notebook. So over here we can see we will be importing the pandas library as PD, and we are going to import the NumPy library as NP. So these are basically the initial and the essentials library to load some data, to play with the scalar, the dimensional, the array values within the Python and Jupyter notebook. So in Jupyter notebook you have to type these import pandas as PD and import NumPy as NP, as you can see on my screen. So we will just execute this command and go to the next step. So series in Python, series is one-dimensional labeled array capable of holding any type of data like integer, strings, floating point numbers, Python object, and etc. The access label are collectively referred to as the index. The basic method to create series is to call like s, we are assigning a variable, and PD, as you know, we have assigned the PD to the pandas library over here while we were importing the pandas with the notation PD. And over here we are using the series, and this is the functionality of the series, that we have to import some data over here and separated by the comma, and we have to index the index labeling of the data over here. So we can use by default or Python. There is some default function in Python that is generate index of the data automatically, and if there are some customized or if we have to assign the labeling, so we can type our index on our data on our own. So we will be learning how we have to include this index and series in the data in the next queries. So here data can be adds many different things like a Python dictionary or ND array and a scalar value like file. So we will be learning these three things in this video of the series in Python. The pass index is a list of access labels, as you can see guys on my screen. Each column in data frame is a series. So over here you can see the columns, two columns and the rows. So we denote it as the series in the Python or the data frame, right? So over here in the first query we can see we have assigned as variable, and we have imported the notation, and we are assigning the starting with the pandas library PD, and we have written dot series, NP usually generates the random number. So NP is NumPy, the numeric library or the numeric module in Python that is basically used to generate random numbers, the probabilities distribution and many things. So over here, np.random, we are generating the random numbers over here. So rand n, so random numbers to the range 5. As we know, we are opening the uh, round brackets with the integer number 5, and over here you can see separated by comma, we are assigning the index of the data by labeling them A, B, C, D, E. So you can see we have written these labels in square bracket with double quotations over here, and over here we are closing the bracket of this series function over here. So basically the green is highlighted starting from the series and random. This is basically the data that we are generating over here, and this is the index that we want to generate the labels of the data over here. So let's run this query, and over here we want to see that how the series is generated by the random number over here, and we want to see whether the labels that we have mentioned over here with the index are appearing or not. So we will be running this query, and we can see the random numbers are generating on the first column, and over here we can see the index labels are on the left side, and on the right side we can see the random numbers with the range of 5 as mentioned in the function, the second query of S. So these are the random number generated by the PD series function, and you see how in a beautiful way we have written and labeled these random numbers by labeling them in alphabetical order A, B, C, D, E. And you can see the D type. Here is the D type, and it's mean the data type that is float. You can see in decimal forms over here as a fraction form. So if we execute once again, we will see maybe the random numbers are changing over here, right over here. So if we have rerun the query over here in the fifth statement, and you can see the random numbers are changed over here. Now we want to see the index that we have entered, and we want to see the index labeling of the above data of the S. We are writing the S variable over here with the dot function, that is index. So let's run this query. We can see the index that we have given input to the data of the series function are appearing in the index labeling over here with the D type object. Over here the label, the data type is object, and the integer over here, the random number, the D type was the float. So the data type was float for the fractions, the random number and the index is the object because they are written in the single quotation as the string values. Over here we are generating once again the random number within the range 5 by assigning the variable b, and we can see we have not given the index labeling as above over here. So we want to see what will be the index labeling generated by the Python itself. Okay, now we have run this b query and we will be executing this b variable. So we can see in Python the pandas library has generated the labels, the index automatically starting from 0 1 2 3 4, and over here the random number is generated in the float format. The data type is float. You can see over here in the second column, and the first is the index that is generated by the random number 5. So if you want to generate like 10 within the 10 range, in the range 10, so we have to rerun it again, and we will be seeing that in B the range is increased from 0 to 9. The total count are 10 in range, and the data type is float. So this was basically the topic of our Python series, the data and the random number generation. Over here we are introducing the series in dictionary. We can see the difference in the series, and by assigning the variable in a dictionary format. The dictionary format is opening by the curly brackets. Over here we are assigning the labels before the first value of the series. Over here we have written 1, 0 and 2, so these are the series value of the data. And over here B, A and C, that is written in inverted commas, double quotation, so these are the index. So now we have assigned these dictionary into the series format. And over here, okay, first we will execute this query, and after that this one. And you can see over here the index is basically BAC. You can see we have written BAC, so this is not in alphabetical order. We have written the B at the first, that is value 0, A then 0, and the value of C, that is 2. So you can see the data types integer. We have written the 1 as a whole, 0 as a whole number and 2 as a whole number. So the value of the data type is integer, and it's giving the series value as an integer. Once again, we have assigned the D variable with the in alphabetical order. You can see A, B and C, and now you can see the values are in decimal, so the values are in a float format. So let's run and check what will be the dictionary. So over here we are converting the dictionary, the D, the curly bracket, putting the into the series PD0 PD, and we will be executing this query. So see, the data type of this series is float 64. Now we are assigning a new range, new index labeling to the series D, but we can see over here we are having only 3 values right here, right? So if we assign one extra labeling or one extra indexing into the series D, we have written already D series over here. So let's execute. So we can see there was no such value in D, and it said this value of D has given us the NaN. So NaN stands for not a number, because there is no such value of D in the dictionary over here. We can see we have A, that is 0.0, and B is 1.0 and C is 2.0. So once we have labeled or assigned, basically we have re-indexed the series of D, so we can see we have arranged in B, C, D and then A. So the data output we can see on the window is basically 1.0, 2.0 and D, because there was no value of D in the dictionary. And over here A, we can see we have value of 0.0 as mentioned above in over here in the form of D. So this how we can see we have added a new value or the new row with the label indexing with the D with a not a number with 0 value, because there was no value exists in the dictionary. And the data type is float. As we can see, all values are in fraction form, like 1.0, 2.0 and 0.0. A scalar value in a series. So we can see we have written a series with a 5.0, and there are 1, 2, 3, 4, 5 index labels. So when we will run, we will see all the labels have a scalar value, the same value, that is 5.0, because we have not assigned a dictionary over here, and we have not assigned any random number or generated any random number within the range 5 or 6 or 7. We have just given a fixed value, that is 5.0. So we call this as a series scalar value over here. And we can see the data type is float, so we denote this as a floats at 64 because these are fraction value. Over here series is ND array. So series act very similar to ND array, and it's a very argument to the most NumPy function. However, operations such as slicing will also slice the index. So basically over here when we want to import the data without index label, so we use nd array function over here. So we will be learning that how useful array will be uh, in our when we'll be using these series data in our data frames without the index labeling. So over here we are generating the variable e with a random number 10 with no index labeling, right? So we will see over here the Python will generate the index by default. So you can see the random numbers are generated with the range 10 with data type float, and over here the index labeling are generated by the Python pandas library. And over here we can see we want to obtain a value that is having the label 2. So we assume when we write e square bracket 2, we assume that we will obtain the value of 1.801134. This is basically slicing, and if we want to obtain the value within the series function. So if we want to obtain a single value, that is basically slicing. We call this slicing in our common term in the Python pandas data manipulating. So we have obtained this value over here. Now we want to obtain the median. Median is the function of within the pandas and numpy, and we will be running and executing this query. So we can see the median value of the series is 0.242142266 and so on, and we want to obtain the values of e within the series that is greater than the value of the median. So over here we have obtained the value of median 0.212, and we want to obtain all values within the series that are greater than the value of the median. So let's run and check. So there are total 1 2 3 4 5 values that are greater than the median value of within the series over here. So the data we have executed this command with the e square bracket open e and greater than sign, and we are using the function e median of the numpy bracket close and the square bracket over here. So over here we are obtaining the values that are greater than the value of the median within the series, and the data type is float. Over here we have to obtain the three values, multiple values within the series, and we want to obtain the 4 and 3 and 1 over here. So when we execute this query, we will see we are obtaining over here 4 3 1. So we can see the 4 value 0.323 and 3 is minus 0.9, right, and 1 is 1.477 over here. And we want to calculate, and we want to know the data type of the of e series. So when we execute and check, so data type is basically the float. As we can see in every query, it denotes the series with a float 64 function, as all values are in fraction. Over here we are using the array because, as we know, we want to obtain the series without index labeling, and we want to just obtain all the values of the series. So we write array, and we have to obtain all the array value of the series. So we have written e dot array. We are calling the e series with the function array. If we execute this, we will be saying we have obtained all the the range values. If we count 1 2 3 4 5 6 7 8 9 and 10 values, these are all the values that we have obtained over here. And we can see there is no index labeling over here, only the values are obtained over here, and with the length of 10, and the data type is float 64. So what is the purpose and reason why we do obtain the array, and how it can be useful? So accessing the array can be useful when you need to do some operation without the index to disable automatic alignment. For example, series array will always be an extension array. Briefly, an extension array is a thin wrapper around one or more concrete array like a numpy and d arrays. Pandas know how to take an extension array and store it in a series or column of a data frame, while series is nd array. Like if you need an actual nd array, then use series to numpy. So over here we can see we have array over here, and we are converting this array into a numpy value. So if we execute this, we will be seeing like over here, if we type e array, so how this array looks like. Okay, so if we execute this now, we will be saying the array, all the values are now is aligned in a proper way within the array format. So we can obtain these array in our future data frames, if you want to cover into data frames. Now we can also assign a new variable, a new value into the ninth length over here. So we can see we are having the value in ninth, that is basically 0.10326. now we will be assigning it to the one. So we can assign a new value into array into the ninth indexing. So we can see the last value 1.05326 will be converted into 1. So let's run and check. E underscore array. So we can see the last figure of the ninth count, the value is converted into the value of 1.0, that is we have assigned over here with the assignment operator. Now we've also obtained by doing slicing. We can see now the value of the array 9 is basically 1.0, and our series is looking like same as we have obtained over. So we have done a slicing over here into the array, and we have done slicing into the series as well. And over here we have understand like how to convert to the numpy arrays or into the a very well managed or a disciplined data type. So we can use array function over here. So guys, this was the just start of the data structure, that how we have to obtain the series data, how we have to align, and what are basically the pandas and numpy library. We have understand like how to convert series into a different scalar value, and into the dictionary and generating the random numbers. We have also understood the indexing and how to remove the index by using the array type function. So guys, in future we will be learning more about the data frame. We will be learning about the data handling, missing data, the data operations, the merge, the grouping, the time series, the plotting, the pivot tables, and many other things. So keep watching my videos. Do like my channel, subscribe. If you want to understand something, do comment. I will respond your comment, and subscribe my channel as much as you can. Thanks for watching guys. Take care. Bye bye.